Welcome to Study Loop.
Okay, so in the first part of this problem, we are mixing up two solutions of sodium hydroxide. That means to find out the final concentration of each ion, as we are mixing up two solutions of same compound, first you have to calculate the individual number of moles for each solution, and then we have to just add them up to find the final number of moles, and then you have to divide that final number of moles by final volume, and that will give us the final concentration of sodium hydroxide. From here we will be able to say the final concentration of the ions present in this solution. So let's first write down the number of moles from each sodium hydroxide solution we will get. So here we have 42 ml 0.170 molar. So the number of moles for this solution will be 0.170 molar or mole per liter times the volume, which is 42 ml, and if we convert it to liter by dividing it by 1000, we'll have 0.042 liter, and it will give us the number of moles for this solution, which is 0.00714 mole NaOH. And for the second solution, we have the concentration as zero point 0.4 mole per liter, 0.4 mole per liter, and we have the volume as 37.6 milliliter or 0.0376 liter, and this will give us a molar number of moles of 0.0150 NaOH. Now, so the total mole of sodium hydroxide will be sum of these two. Just if we just add these two up, it will give us a value of 0.02 mole sodium hydroxide. And if we just add up the two volumes, total volume here is the sum of the two volumes, which are 42 plus 37.6 milliliter, 79.6 milliliter. If we convert it to liter by dividing it by 1000, it will give us 0.0796 liter. Now, to find out the final concentration, we simply the final number of moles, which is 0.022, over the final volume, 0.0796, and from here we can find out the final concentration, which will be 0.278 molar. So this is the final sodium hydroxide concentration in this solution. Now, sodium hydroxide will be dissociated to give us sodium ion and hydroxide ion. Now, since from one sodium hydroxide we will get one sodium and one hydroxide, that means if the sodium hydroxide concentration is 0.278 molar, that means the concentration of sodium ion will be 0.278 molar, and the hydroxide ion concentration will be also 0.278 molar. So these are the concentration of each ion present in the final mixture of sodium hydroxide here. Now, in the second part, we're we are mixing 44 ml of zero point 0.1 molar sodium sulfate with 25 milliliter of 0.15 molar KCl. So what we have to do is we have to find the final concentration of each compound here, and from there we'll be able to calculate the final concentration of each ion present. So first you find out the final concentration of the Na2SO4. So for Na2SO4, the initial concentration or M initial is 0.1 molar, and initial volume or V initial is 44 milliliter. And if you convert it to liter, okay, we don't need to convert this to liter right now. We can keep it like this. And so what we'll have to use is we'll have M initial V initial equal to M final V final. We will use this formula here. So the V final is the total volume, which is the volume of this Na2SO4 plus the volume of the KCl we are adding, that is 25 ml. So the total volume will be 69 ml. Now here we know the M initial, V initial, and we know the V final. We can find the M final or the final concentration of Na2SO4 after the addition of 25 ml KCl. So V final for Na2SO4 will be M initial, which is 0.1 times the V initial, which is 44, over the V final, which is 69, will give oh, okay, so this is not V final, this is M final, the final concentration of Na2SO4. So this will give us the final concentration, which is 0.0638 molar. Okay, so this is 69 liter, and here we have molar. Okay, so this is the final concentration of the Na2SO4. Now we have to see how Na2SO4 will be will be dissociated. It will be dissociated as Na plus plus SO4 2 minus. Now if you want to balance it, we have 2 sodium here, that means we will have 2 sodium here. Now if the initial concentration of Na2SO4 is the final concentration of Na2SO4 is 0.0638, which we just have calculated, then the final concentration of sodium ion will be 2 times this concentration. That means 2 times 0.0638 molar, which will give us 0.128 molar. And the sulfur ion concentration will be like this, because from 1 molar Na2SO4 we have 1 molar sulfate produced. That means the sulfate ion concentration will be same as the sodium sulfate concentration. Now we have to find out the concentration of the ions present in KCl. So we just utilize the same process. For KCl, initial concentration is 0.15. Initial volume is 25, and final volume is volume of KCl plus the volume of sodium sulfate, which is 44, and this will give us a total of 69 ml. Now we can calculate the final concentration of KCl, which will be just multiplication of initial concentration times the initial volume 25 ml over the total volume, which is 69 ml. This will give us a value of 0.0543 molar. So this is the final concentration of KCl. Now I have to see how KCl will be dissociated. KCl will be dissociated to give us K plus and Cl minus. That means from 1 molar KCl we will have 1 molar K plus and 1 molar Cl minus. So if the KCl concentration is 0.0543, that means it will give us 0.0543 molar K plus and 0.0543 molar Cl minus. So the concentration of each ion present is K plus ion concentration is 0.0543, Cl minus ion concentration is 0.0543, and the Na plus ion concentration is 0.128, and sulfate ion concentration is 0.0638. These are the concentration of each ion present in this mixture. Now in the final one, we are mixing 3.6 gram KCl in 75 milliliter of 0.25 molar CaCl2. Okay, so first we'll find out the concentration of KCl, as we have given the mass of KCl. So to find out the concentration of KCl, first you have to find out the number of moles of KCl, which is mass of KCl over its molar mass. So you're given the mass as 3.60 gram, and the molar mass of KCl is 74.55 gram per mole, and this will give us 0.0483 mole. So this is the number of moles of KCl. Now we have to find out the concentration of KCl. So we just divide this number of moles by the volume of the solution, which is basically the volume of the CaCl2, 75 ml. So concentration of KCl will be the number of moles of KCl, which we just calculate as 0.0483, over the volume of the solution, which is 75 milliliter or 0.075 liter, and it will give us the concentration as 0.644 mole per liter or molar. So this is the final concentration, or this is the concentration of the KCl in this solution. Now we have to find out how KCl will be dissociated. KCl will be dissociated as K plus Cl minus. That means if KCl concentration is 0.644 molar, that means K plus ion concentration will be same as the KCl, and also the Cl minus ion concentration will be same as KCl, since from 1 molar KCl we will have 1 molar K plus and 1 molar Cl minus. Now we have to find out the concentration of the ions in CaCl2. So since we are not adding any other volume here, that means the CaCl2 concentration will remain same. So just we have to find out how CaCl2 will be dissociated. So CaCl2 will be dissociated to give us Ca2 plus 2Cl minus. Now the CaCl2 concentration is 0.250 molar, and since from 1 CaCl2 we are producing 1 Ca2 plus, that means calcium ion concentration will be same, but we are having 2 Cl minus from 1 CaCl2, that means uh, the Cl minus or chloride ion concentration will be 2 times the calcium chloride concentration, which will give us 0.5 molar Cl minus. Now, so we have Cl minus or chloride produced from this one and also from the KCl. So the total Cl minus concentration is this concentration plus this concentration. That means the final mixture chloride ion concentration will be 0.644 plus 0.5 give us 1.14 molar chloride ion, and K plus ion concentration is we have calculated as 0.644, and the calcium ion concentration is 0.25. So these are the final concentration of each ion present in this mixture.